would you, first of all, before we look at these charts, would you go ahead and look at example number 1 and let me show you what a piecewise function is. This is a piecewise function. It has this piece right here that has a 0 slope. And this piece right here is increasing and it has a positive slope. And this part right here is decreasing and it has a negative slope. This is also decreasing. This is also has a negative slope, but it has a different negative slope than that negative slope. And all these pieces are put together. Therefore, it's called a piecewise function. That's all a piecewise function is, when you put the different pieces together. Now, there's a lot more you can talk about when you talk about piecewise functions. You can find the equation for each one of those pieces. You can talk about which pieces are increasing, which pieces are decreasing. But all I need to tell you at this point is that is a piecewise function because it has different pieces with different slopes and different characteristics. So, does this part right here look like what we were doing last week? It should look like what we were doing last week because it is what we were doing last week. When we were doing those number lines, we were finding the domain because the domain is the x values, and when you have a number line, that's all you have is x values. And when you are writing down the domain, you always go from left to right, from smallest to largest. The domain is always from smallest to largest. On the number line, that would always be from left to right. When I write this on the board, you write it on your paper. So I haven't yet seen some of you pick up your pencils and write this part down on your paper. Just like we were doing last week, if they were 2 endpoints, this is how you format the inequality with 2 endpoints. This is how you do the interval notation. This is the same thing we were doing last week, just all together in one chart. And this second chart is what if you only have one endpoint. If you only have one endpoint, what do you see first every single time if you have one endpoint? X. If you just have one endpoint, does the endpoint come first? No, the X comes first. Okay. So, now we are ready for example number 1. So, first question up there, is it a function? Do we remember the vertical line test? The easiest way to tell if something is a function that's on the graph is using the vertical line test. So, first of all, which way is a vertical line? Up and down. So, would this be a vertical line right here? If I take this vertical line, how many times does it cross my graph? 1, right there. Is there anywhere I can put this vertical line where it would cross my graph more than one time? No matter where I put this vertical line, it is only going to cross my graph one time. That makes it a function. There are several definitions of a function. The easiest one for me to understand is for every x, there is only one y value. Okay, so next, we are going to write the domain. We're going to write the x values in terms of inequality, interval, and set builder notation. 3 different notations to say the same thing. Now, what is domain? X values, left to right. So you are going to take your little pieces of fettuccine and you're going to line this up with the point farthest to the left. And then you're going to take your other piece of fettuccine and you're going to line it up with the points farthest to the right. You're going to line it up on the left-hand side and the right-hand side. This distance in here in between is the domain. How far is it this way? 1, 2, 3, 4, 5. To the left, that makes it -5. I most always do interval notation first because I like it best. This goes 1, 2, 3, 4. To the right, I'm counting from 0. Now, over here at the left side, that's a closed circle. So this is a square bracket. Over here on the right, it's an open circle. Our interval notation rules say closed circles with square brackets, open circles with parentheses. This is a review of what we did last week. Only last week we were doing 1 dimension, now we're looking at 2 dimensions, but we're just looking at the x values. To take the interval and make it into inequality if it has 2 endpoints. If it has 2 endpoints, the x goes between the 2 endpoints. It is always less than signs pointing to the left because it is always in order from smallest to largest. Saying it's in order from smallest to largest is the same thing as saying it goes from left to right, because the smallest are on the left and the biggest are on the right. Now this needs one more thing. This is a closed circle over here, so this one needs an or equal to over here on the left. Next, set builder notation. I am going to copy down exactly my inequality notation, and in order to be set builder notation, it needs to have brackets around it, and the X bar, the bar stands for the word such that, out in front. It is not set builder notation if it doesn't have brackets. The rule for sets is they are in brackets. I saw that on the test, some people getting everything else right, but they left the brackets off. That is not set builder notation without the brackets. Questions? No questions, we can look at example number 2. Example number 2. So, here is my vertical line test. Vertical line goes up and down. When I put my vertical line on the graph, it crosses the graph 1 time. Is there anywhere I can put this so that it crosses the graph more than 1 time? Every place that I put my vertical line, it crosses the graph only 1 time, so yes, this is a function. Now I'm going to put my fettuccines, my vertical lines, I'm going to put it on the left-hand side and the right-hand side. Except over here. Oops, I didn't mean to do that. Over here. Is that a point? That's an arrow. What does that mean, that it's an arrow? It keeps going. How far does it go? Does it go all the way off the graph? So move that line all the way off the graph. Does it keep going and going and going? How far does it go? infinity, and so in interval, now it's going to the left, so it would be negative infinity, and then this one would be 1, 2, 3, 4. Infinity always has a parentheses around it because I can never go put a point at infinity. It's too far away, so to speak. And so this one would be down here. I have a closed circle, so it has a square bracket. How many endpoints do I have? One endpoint. When you have one endpoint, the variable comes first. Now, this arrow is going off to the left. Left is less than. And this has a square bracket over here at 4, and so this is less than or equal to. And in set builder notation, this is x, such that x is less than or equal to 4. This is the same as this with these brackets around the set builder notation. That is the domain. The domain is left to right. The domain is always smallest to largest. And then we have range. What is range? Y values. Now, you've got to remember that when you take Y values, it's always smallest to largest, and the smallest Y values are at the bottom. Don't be backwards. The Y values are bottom to top. The chart is exactly the same, except instead of having X's, I have Y's, because range is in the Y direction. The charts are exactly the same, except instead of having X's, you have Y's, because it's in the Y direction. Range is in the Y direction. So now I'm going to take my fettuccine, and I am going to put this at the bottom and at the top, because range is bottom to top. Well, where is the bottom? The bottom is -2. Where is the top? 1, 2, 3, 4. See where I get the -2 and the 4? I'm counting bottom to top this time. I'm ignoring left to right. Now, this one's a little tricky, because down here at -2, I have a closed circle, and I also have an open circle. Which one do I use? Closed or open? I got both. Nope. Closed is better than open. So if you have a choice, here I have both closed and open. So here there is something closed, so that would be considered closed. Even though I have both a closed and an open down here at the 2, I use the closed. Now up here at the top, I don't have any circle at all. I don't have a closed circle or I don't have an open circle. This is where you go back to your geometry. The intersection of two lines is a point. Even though there's not a dot written there, that is a closed point up there at the top. If it doesn't have an open circle, it will be closed. And so right here at the top up here, that's considered closed. There is no open circle. Okay, if you have an inequality with two endpoints, the variable is between the two endpoints. The inequality points to the left. It's less than. It's always less than. You can never have inequalities pointing the opposite direction. You can never have a compound inequality pointing greater than. This has to be less than because it has to be in order from smallest to largest. Now, since both of these are closed, I need an or equal to on both of those. Set builder notation is the same thing, except with the brackets around it and the y bar. Do you know why I have y's instead of x's? Because it's range. Range always goes with y. The variable on the range will always be y. Anybody need a minute? Okay. Example number 4. On example number 4, somehow these are Okay, I'm having difficulty with my line segments here. So, this one right here is at the top. This one right here is at the bottom. But is that really true? What's not true about it? Is this one right here, is that really the top? Does it stop there? How far does it go up? It goes up to infinity. Now, hold on. It goes up. Up is positive. And so it goes up to infinity. And where's the bottom point? 1, 2, 3, 4. Now that's not right. Do you know what's wrong with it? Is it in order from smallest to largest? Is it in order from bottom to top? It is not in order from bottom to top. What is the bottom point? There's not a top point. It just keeps going up and up and up. And so that is positive infinity. And so also, please notice, this bottom point here is not the end point. The end point, this is not necessarily from end point to end point. It depends on the graph. This is bottom to top. Okay, so if I have one endpoint, the variable comes first, and then I have the endpoint, and it's getting bigger and bigger and bigger as it goes off the top of the graph. It is greater than or equal to because it is getting bigger and bigger and bigger. But I have a question as soon as I get this written down. I thought we said on example number 2, you see that this is the same graph as example number 2? I thought we said on example number 2 it was negative infinity. And this is positive infinity. How can this be negative infinity on example number 2 and positive infinity on example number 4? This is domain. To the left, it is going to negative infinity. That's left, right. It's going off of the left, that's negative infinity. On this example number 4, it's going off the top, and that's positive infinity. What is very difficult with domain and range is learning to separate left and right from up and down in your brain because we see it as one graph. But when we talk about domain, we have to just think about the x values left to right. When we think about range, we have to think about the y values bottom to top. And you have to do that same thing in physics. Any of you in physics? When you get to your motion equations, you will have motion equation in the x direction. You will have a separate motion equation for the y direction. You have to figure out the motion in the x direction and the motion in the y direction separately. The same kind of thing here, and that is what these little lines are helping you do, is to separate the domain and range in your mind. Okay, example number 5. Domain, we start with domain, and so domain, here is left, and here is right. Is that correct? Is that where it ends on the left? Where does it end on the left? It has arrows. It keeps going, so we're going to move this all the way off the graph. Does this stop right there? Do you see the arrow? The arrows are not only pointing up, they're pointing out. It's going to the left and to the right, outward. How far is it going to the left? How far is it going to the right? I hear some of you muttering. It is going negative infinity to positive infinity. It's going to the left forever and to the right forever. We're not talking about up and down now. You have to separate it in your brain, left or right. There are several different ways to write the inequality. I am going with the easiest way. In inequality notation, you can just write this fancy looking R. You can write out the word. All real numbers, that's what the fancy looking R stands for. In set builder notation, this is what it would look like in set builder notation. Range, Y values, is bottom to top. But is that really the top? The top has arrows on the end. What do the arrows mean? It keeps going right off that graph. Move that right up there off the graph. It keeps going off the graph forever. So in interval notation, it has a bottom point at -2, and then it goes right off the top of the graph. It is, in inequality notation, y is greater than or equal to -2. If it goes off the top of the graph, it's getting greater and greater and greater. In set builder notation, y such that y in set builder notation, you have to have the brackets. Is it a function? Okay, here's my vertical line. If I put my vertical line on the graph, how many places does it cross my graph? If I put my vertical line in a different place, how many places? Is there any place where I can put my vertical line where it's going to cross the graph more than one time? So, The vertical line crosses the graph only one time. Yes, it is a function. This should be a function you have seen before. Do you know the name of this function? The name of the graph, the U shape, is parabola. That's not the name of the function. Anybody know? You should know. When I say the word quadratic function, is that something you've heard of? This is called a quadratic function. The shape of the graph is a parabola. The name of the function is a quadratic function. Now, just to show you the difference, it helped my other class to do this. If I had a graph, that's a parabola, but it's not pointing the usual direction, is it? That is a parabola, and would this parabola cross the vertical line test? Is that parabola a function? This is not a function because my vertical line crosses it more than one time. So that helped some of my previous class to understand what a function is by showing them something that was not a function. Another classic example of a function would be a circle or an oval. How many times does that cross the circle? Twice, so it is not a function. Now we're going to come back to example number 6 tomorrow. Example number 6 is a little bit different. Instead of giving you the graph, you have to make the graph, and we'll do that tomorrow. When I find your test.